Let's have an example of Bayes' theorem with more than two events. Three machines, A, B, and C, produce respectively 60%, 30%, and 10% of the total number of items of a factory. The percentage of defectives output of the three machines are, respectively, 20%, 3%, and 4%. An item is selected and is found defective. Find the probability that the item was produced by machine C. Pause the video and try to see if you'll be able to answer this problem. So let's illustrate this one. We have again our total set here. There you go. And then we are told that for machine A, it's 60%. So a little bit here. There you go. So the 60% of the total number of items in the factory belongs to machine A. And let's write that down. 60%. Then for B, it's 30%. So we are going to have it here. There you go. There to represent our B, which is 30%, leaving C 10%. There you go. We are told that the percentage of defective outputs of the three machines are respectively these amounts. So that would mean for A, it's defective 20%. So I'll probably make this a bit high. Probably here is good. There you go. This is 20% of the 60%. So the defective will be the 20% of 60%. And that would be equal to 12%. There you go. For B, it's 3% because it says respectively A, B, C. So that's following that pattern. So it's 3%. That's probably something like this here. I don't know if it will fit. So let's scroll down a little bit. There you go. And the amount defective now would be, the amount defective would be 3% of our 30%. Oops, that should have been written in blue. So it's easier to distinguish. And that's actually equal to 0.9%. So there's 0.9% here. Well, here it's 4%. So just a few, very, very few bars I have here. Let's just have this one here. And our defective in machine C would be 4% multiplied by 10%. 10%. And that would be equal to 0.4%. So 0.4%. So this is what we need. What's the probability that the defective item will be produced by machine C? So overall, that's a 0.4% chance. But out of the defectives, which is the probability that the item is from machine C given that it's defective, would be equal to the 0.4% rather, all over your 12% plus 0.9% plus 0.4%. And this will be equal to 4 over 133 in fraction form. In decimal, it's approximately 3.01%. So there's 3.01% chance that the defective item that was drawn is from machine C. Now, how do we solve it using our formula? So let's scroll down that a little bit more. There you go. So this same here, the probability of getting C given it's defective would be as follows. The probability of C multiplied by the probability that it's defective given it's from C all over these values now. The probability of A multiplied by the probability that it's defective given it's from A plus the probability that it's from machine B multiplied by the probability that it's defective given it's from B, and this amount plus the probability that it's from machine C multiplied by the probability that it's defective given it's from machine C. There you go. And these values are actually the ones that we have solved already here. So the one on top would be our 10% multiplied by 4%, 4% all over these values, which is our 60% multiplied to 20% added to our 30% multiplied to 3%, and I don't have space. Let's extend that a little bit. Oops. There you go. So now we have plus here, this one here, 10%, which is actually the one on top, times 4%. And we are still going to get with this value. So therefore, the probability that the item is from machine C given it's defective is 4 out of 133 chances, or 3.01%.